Welcome back, everybody. What we will take a look at this time is how to deploy network address translation. I'm going to start with a discussion of the configuration syntax. So we will talk about the different GUI options that we have to configure to deploy NAT, and then we will take a look at an example where I'm going to show you how to use NAT in my network. The first thing that we will want to configure the main thing that we will want to configure as we deploy NAT is going to be NAT policy. So this is something that we will do from the policies tab, then down to NAT. Now, as a best practice, and also something that I recommend to use when you work with NAT, either as you practice or especially in production, is going to be to create objects for both the information, the data that you will use inside of the security policy, plus different objects easily distinguishable from what you normally use in the security policy, just for the purposes of configuring your NAT policy rules. So for instance, if you plan to do the translation for one of your web servers using IP address, let's say X, as the translated address, the new address for this server, I would build an object and call it like nat-x or a nat-server x, or basically nat-server, something like this, just to distinguish these objects and NAT objects used within the NAT policy from the objects, regular objects that you configure inside of the security policy. Of course, also notice that some of the NAT objects, you will still use them in the security policy. It's going to all depend on what type of translation you configure and how. Okay, so objects is also how we will define IP pools when we want to perform dynamic NAT, deploy dynamic NAT. This is something that could potentially require additional routing changes. Maybe let me show you an example here in this topology. So assuming that I wanted to configure a network address translation for my internal clients, and this would be an example of a source network address translation. So I'm saying that I want to change the sources from 10.1.10/24 to something else. I have literally two options as how I can accomplish this. I can either use the outside subnet as the new addresses for my internal devices. So this is option one. And the new IP addresses from this outside zone, outside interface. And the second option is going to be to use a non-outside IPs, so basically addresses other than this 192.0.2/24 in this example. So in this case, I would say excluding 192.0.2/24, something else. And this makes a difference because if you decide to build a pool using the subnet allocated to the outside interface of the firewall, outside zone in this case, something that the router to the upstream device is immediately know how to reach. You don't have to think about making any type of routing changes on the upstream device, so in our case on router 2. Because router 2, when it gets reply packets sent back to the internal clients, it is going to see those packets destined to 192.0.2/24, which means that it is going to send the reply back to the firewall itself. But if you select a different pool, like let's say I choose to do the translation using 192.12.2 0/24. Just an example. You always have to think about routing configuration of the upstream device, in this case router 2, so it knows how to get back to this destination. So the question is my upstream device router 2 know how to get back to 192.12.2.0/24? Because if it does not, you will have to tell the router that to get to this destination, to get to this prefix, it should be sending packets to the firewall. So in this first case, excuse me, this is actually known as proxy ARP. So it's like the firewall is gonna know that when it does the translation to a non-local address, it is also supposed to kind of like own it for the purposes of performing this layer 2 to layer 3 resolution with ARP. But your upstream devices must be properly configured to point to the firewall for this to work. Okay, so something to remember about when you work with a NAT and IP pools on any type of device. Okay, the other thing that you should consider is going to be adding objects for hosts, subnets, individual devices that will be subject to translation. Okay, for verification, we will be using rule usage. Maybe let me quickly open up the policies and then take a look at NAT. So when we eventually add the roles to the policy, we will also see the information about the hit counts. So the same exact approach as what we typically use when we work with security policy. Another one is going to be troubleshooter, which we can access from device troubleshooting. So we will take a look at this stuff when we create at least one NAT role. Just remember to switch, select the task to NAT policy match. And then we've got a bunch of CLI commands. We will use show running IP pool to check out the pool, take a look at the pool, show running NAT role IP pool, or show running NAT policy to see the policy roles on the command line and to see the allocation from the dynamic, for the dynamic NAT from the pools. Show session is going to tell us about the actual traffic that is subject to translation, including the information about the NAT that affects the session, and show system state is something that we can quickly take a look at. We can use to quickly take a look at the platform limits for network address translation. Maybe let's actually start with this one before we start our configuration. Okay, so let's connect to the firewall, to the command line. Show system state and match NAT, but with hyphens before and after. Okay, so this one once again is supposed to show me the limits, platform limits for NAT. Like the NAT policy role, this is basically talking about dynamic network address translation, the number of roles that it supports, I believe. And this is the number of addresses it supports in the pool. And this is for a DIP, so dynamic address translation with ports. So basically a port number translation. Okay, the first example we will take a look at is where I'm going to show you how to perform source address translation on the internal connections, on the connections traffic originating on the within the inside zone, because we are on the inside here. So we are concerned with the inside to outside direction because we want our clients to be able to reach the internet and also router 2. Now, router 2 is actually what we'll use to test this stuff. So since we are on RFC 1918 IP addresses, we don't really want to use them. We will assume that this is a part of the public range, because actually it is, but this is technically a reserved network. So we will want to allocate, create a pool from this subnet that we own, a subnet of public addresses to hide our clients and eventually allow them to reach the internet. Okay, so let's say that the pool that we will create is gonna start with 192.0.2.51, and it is gonna end with 192.0.2. Let's say 59. We've got 9 addresses in the pool, and once again, this is gonna be an example of a source network address translation. We will be only changing the source addresses here. First thing that we will do is that we will actually start creating objects. So I'm going to go to Objects, Addresses, and first I'm going to create an object for my internal subnet. LAN 1 is 10.11.11.0/24. Okay, the second internal network is 10.1.0/24, 10.1.1/24. And we will also need an object to represent our NAT pool. NAT-pool inside, like for our inside clients, where we will configure it as a range of addresses from 192.0.2.51-192.0.2.59. We've got 9 addresses in the pool to match our example. So now we can proceed with policies NAT. We will add a role that I will call NAT inside users. The type is going to be set to IP version 4. And now under original packet, remember that for both network address translation policy and security policy, when we select the zones, the source zone is always gonna be set to the interface where the packet is received on. So original packets from the users in our case will be coming from the inside interface, which is part of the inside zone, which means that I will have to select a source as inside. Now, since the traffic is going to be going to for the outside interface, my destination zone is going to be set to outside. We don't configure, well, we will select the sources, the original sources that will be subject to translation. So both of my internal subnets, 10.1.1 and 10.11.11, the green stuff. And now destination is going to be set to any because we allow people to reach any destination on the internet. We will also leave the destination interface set as any, like if we potentially have more than one outside port, and the service is also going to be configured as any. The translation type is going to be set to dynamic IP, where the translated address is going to be configured as my pool. Okay, you also have an option to configure a fallback to perform port address translation, DIPP, either with the interface or another address, but I'm going to say I don't want a fallback. And the destination address translation is not going to be performed. This rule is just for the sources. Okay, so I configured my source addresses, destination as any. This is inside to outside. We go, as I said, in this direction, from the right to the left, inside to outside. Okay, so another thing that we will now have to do is going to be to configure a policy rule that is going to permit this communication. So again, remember about the different pieces of the information that you want to include in the security policy rule in this case. Addresses, you always use the original addresses seen in the original packet. So in our case, it's going to be the real sources and the destination. We will use any. And then for the interfaces, source interface is where we get the packet, which is going to be inside, so inside zone. And the destination zone, in case of a security policy, it is taken based on the destination address. Well, we don't do destination net, so it's going to be the outside zone here, because we take a look at the destination address from the original packet. We perform a fib lookup based on that, and we will use this information in the security policy. We can actually take a look at this on the firewall command line with the test routing fib lookup command for the, in my case, default virtual router. For the destination IP, let's say that the clients will be sending packets to router 2, which is 192.0.2.2. It says to get there, we will route packets out of Ethernet interface 1/2. And when we test this for Google's DNS 8.8.8.8, it says to reach the Google's DNS, I'm going to use my Ethernet 1/2, which belongs to the outside zone. So the same information is gonna be added to the security policy in terms of addresses and sources. The rule type is gonna be set to interzone in user-access -out. So again, pick insight as the source. Source addresses is my internal clients. Destination zone is going to be set to outside with any as the destination address. And let's allow a DNS. Let's permit web browsing here, SSL, and also telnet. So something that we will be easily test with this setup. Just for applications running on the default ports, this is what we want to allow, and we will log at the session end. In the same time, just in case, we will also override one of the default rules to log at the session start, just in case if we have some drops, so we can quickly see this in the logs. Okay, so inside to outside, this is my inside addresses and destination. Any we will now commit. And we will quickly prepare to test this change. So I'm going to open up router 1. Right, router 1. Okay, let's double check commit status. Okay, the commit is fine. We installed the configuration, so we will now go to router 1, and we will try to telnet to router 2, 192.0.2.2. And within this telnet session, I'm going to say who to check our source address. So on router 2 sees the connection as coming from 192.0.2.57. And this is something that we should be able to confirm on the firewall with show running NAT role IP pool. And I want to say for my role NAT inside users. Okay, we see that we've got an xlate. Xlate is basically the translated address. It says that source 10.1.1.1, which is my router 1, got translated to 192.0.257. But maybe let's quickly go back to the GUI and confirm this using information found in the policies. So first and foremost, I want to take a look at my NAT policy to see the hit counts, which I can. And then in the security policy, we should also see some hit counts here for our inside-outside rule, which we do. We could also go to the command line on the firewall and issue the show session all command, trying to match the address of the client. So it shows us, at some point it shows us the address, but this output is not really easy to read. So I would go ahead, and for the details, I would go ahead and say show session with, tell me the details for this actual session ID, 9450. It says, here's the details. The client to server flow looks like this. The client session comes from 10.1.1, which is router 1, and it is destined to router 2. Okay, so this is my router 1, and this is router 2. Now, on the way back, so this is coming in this direction, R1 to R2. This is client to server. Now, on the way back, which is a server to client, so this is talking about the opposite direction from the destination to the source. The source is now router 2, the original address of router 2, but notice what's the destination here. Destination is the translated address of router 1, because this is how router 2 sees router 1 on its network. And this output is also going to tell you about the role that we match in the security policy and about the NAT policy rule. Okay, the same information you should be able to find in the logs. Let's give it a shot. Let's go to traffic logs, and let's say that we want to take a look at the what was the source? 10.1.1.1. Let's filter for sources. Or let's just filter for the destination. Okay, let me also send some packets here for this session. I believe that I'm logging. Okay, let's disconnect. Let's disconnect and wait for the right log to show up here. Because I think that I set logging to log at the end. So let's go back to manual. Let's refresh. This is the log message I wanted to show you here. I'm logging at the session end. So it says this is the translated address for the source, where destination uses the original address, which means that it's not subject to NAT. Or basically the destination address is the same, doesn't change. Okay, so as you can tell, we've got a different bunch of tools that we can use to troubleshoot our configuration. Now, in our second example, we will take a look at how to perform enable destination NAT. So the idea here is going to be to configure a translation for a router 1. And we will focus on the loopback address of this system, which is 172.31.1.1. Okay, so we will say that this address emulates a web server. This is the original address of the web server, and we want to expose it to the outside, to the external users, using a different address. The translated web server address. We will choose something from the outside pool so we don't have to change the routing on the upstream system here on router 2. This is going to be 192.0.2, let's say .161. So we want to represent this web server with a public address on the outside. So this means that this is going to be an example of destination NAT, where the focus is going to be on providing connectivity for the external clients to this inside the system using a static translation, destination NAT. Now, how can we accomplish this? We will still have to go to the firewall and modify the policies, and then modify security policy, NAT policy. First and foremost, configure a bunch of objects. So I'm going to start with defining an object for the original address of my router. Router 1 web, let's say org, like original, is 172.31.1.1/32. I need one more object for the translated address, NAT R1 web, which is 192.0.2.161. And with that in place, we can now move on and configure our policy rules. Okay, so in the NAT policy, we will call this role NAT web R1 IP version 4, where the original packet, so packet coming from the client, is gonna be received on the outside interface. This is my source zone. And now the question is, what is gonna be the destination zone for the packet? We are talking about the NAT policy, which means that the NAT policy is gonna look at the original packet's destination address to perform the fib lookup to figure out the correct zone for the role. And in our case, the original address, so the address that is coming from the client, is gonna actually point to the translated address. So the clients will be sending packets to 192.0.2.161 and not the loopback's address. So we will wanna perform a lookup based on that information. Right, so remember, the people will be sending packets with a destination of 192.0.2.161. So now I need to ask the firewall, how do you get to this destination? And we will take a look at this on the command line with the test routing fib lookup command. What is the syntax here? IP 192.0.2.161. Virtual router is default. Okay, it says you get there via Ethernet 1/2. And Ethernet 1/2 is my outside. This is my outside zone. So this means that in my NAT rule, I want to choose outside as a destination zone, not inside. Okay, sources will be set to any in the original packet, and the destination address is set to the translated address. So translated address is on the outside from the routing perspective. Now in the translated packet, we will leave the source. We don't really want to change addresses of the connecting clients. You could also do the static translation on the inside addresses. And you could even make these translations bidirectional. So it kind of like affects both. It changes the source on the way out, and when someone replies, it also immediately changes the destination, automatically changes the destination, but we will not be changing the sources. We want to focus on changing the destination. So we will basically change, select the static IP here, and select the this is talking about the address after translation, which means that I want to refer to the original address of my server. Okay, so the original server uses this loopback of 172.31.1.1. This is what router 1 uses internally. So I want to choose this address as the address after translation. Okay, port translation not needed. Source we leave it as none. We focus on the destination translation. So the main difference from the previous example is that we are now configuring our zones as source and destination as outside. Then we've got in the original packet, we've got the translated destination because clients will be sending packets to the translated address versus the packet after NAT is going to point to the real address of our server. And then in the security policy, we will configure a similar rule. And there is going to be just one difference in terms of the addresses and zones. Okay, so I'm going to call it router1-web. This is a inter-zone type of a rule where my source zone, okay, where the packet comes from, it comes from the outside. So this means that source zone is set to the outside. Source addresses, we don't know the client addresses, we set sources as any. Destination zone, in case of the security policy, remember that it is taken based on the fib lookup on the address, destination address from the translated packet. So in our case, the translated packet is the original address of the server. So the fib lookup is going to point to the inside. So this is why we want to set inside as the destination zone. So this is the difference from the NAT policy. But if we take a look at the destination address, remember that addresses are always taken from the original packet, and the original packet is destined to the translated address. So this is going to be my destination address. Application, let's enable web browsing. And SSL. On the default port, we will allow and logit session at. Okay, so from the outside in the source zone set to outside, to the inside zone as the destination, and the original address, the address from the original packet. So the packet is destined to the translated address because this is how people see the server. This is what we can now commit. Right, so we will now open up a session to router 2. And maybe in the meantime, I'm going to go to the firewall, and we will also test the troubleshooter. This is a troubleshooter for NAT policy, which means that you want to configure the settings as what you use in the NAT policy. So we want to use the NAT policy logic for the addresses and zones. So this means that we are coming from the outside. The packet's destination is on the outside because this is how we get to the translated address. We are coming, let's say, from 1234, a public address on the outside, and destination is 192.0.2.161. Destination port is going to be set to 80. I want to execute and take a look at the results. it says we should match rule called NAT web R1, which is the second rule. Now also remember that the Palo Alto Networks Firewall does not prioritize static translations over dynamic rules. So ideally, when you configure your NAT policy, you want to put your static specific translations to the top of the policy, just to make sure that you don't shadow, those rules are not shadowed by broader rules that are typically configured with dynamic NAT, like for the sources. Ideally, I'd also want to click on it and say move to the top. This is a specific rule. I want to keep specific stuff on the top of the policy. In this case, we don't have an overlap because this is for the source, this is for the destination. But just to make sure, play safe, put these on the top of the policy. Right, so let's now telnet to 192.0.2.161 using a web port. So we see that we've got a match, and maybe let me also use a copy command, HTTP. So this is going to emulate a real web connection. I'm trying to emulate a real web session on router 2. And maybe let's take a look at this in the log messages. So let's go to monitor the traffic, and let's now change the destination. Let's filter by the destination. So this is our stuff. This is TCP port 80 from router 2. If we take a look at the details, it should tell us about a translation on the destination address. Okay, so we see that the source remains the same. So this is packets from the external client from router 2. And destination, original destination, it says is a .161, where the translated address is the original address of router 1's loopback.